Mm-hmm.
3
Mm-hmm.
joules, but then you're gonna add it up. 3 plus 5, which equals 8.
Mm-hmm.
So you do 10 minus 8, that equals two.
So 10 minus 8, it should be what?
2.
2. So why you are saying 3?
My bad. Sorry, I saw that as B. Sorry, I meant 2. A.
Okay, very good. Now it should be A. This is based on conservation of energy, right? Now, please see this fourth one. A car travels along a flat road. It has 500 billion joules of kinetic energy. Every second, the air resistance and other frictional forces causes it to lose 1 billion joule of energy every second, right? If the car is to travel at a constant speed, how much energy will the engine have to convert to kinetic energy every second? Yeah, please try.
1 billion joules. A.
Correct, absolutely correct. So, see, how much energy is getting lost? It should be supplied, it should be replenished with the engine work done, right? So, its speed will be constant. If engine will do the more work, if engine provide more energy than the energy lost, the speed will goes in up, or we can say speed will increase. If the engine is supplying less energy than the energy loss, then the speed will gets decreased. But here it is saying that energy has to be speed has to be constant. So that's why the engine have to work exactly same amount as the energy lost due to the friction. Okay, now the fifth one. One day car journey may be possible on the moon. Okay, which statement is correct about a car on the moon? Please read your statement and try to answer.
Uh, A. A car would not work on the moon as there is no gravity.
Have you read all other options?
Yes.
So let me read one by one. All of. Let us start from the D. Car on the moon would have less weight than an identical car on Earth. Statement is true. I have to see which statement is correct about a car on the moon. This statement is correct. A car on
Yeah.
the moon would have the less weight. You know, weight is W is equals to mg. This G depends on the planet or the satellite. On the moon, the gravity of moon is 1 by 6 times of gravity of Earth. So obviously the weight of the car on the moon will be less. Okay, not the science question. Explain in terms of energy why a car traveling at a faster speed is more dangerous in a collision. That's very important.
Yeah.
Yeah, can you explain this?
Because everything is just faster.
Okay, so why this fast moving car is dangerous during an accident? See, slow moving car, less dangerous accident, but fast moving car will be a very dangerous after the during a collision. So its answer is all about the energy. You have to think on energy. See, if the speed is high, if the speed is high,
You
The
know,
speed
kinetic.
is high, kinetic.
Are you getting my audio? Correct. The speed will be more, then kinetic energy will be more. And after collision, what is going to happen? After this collision, what will happen? The car will stop suddenly. The car is going to be stopped suddenly, right? So it means its kinetic energy will be zero there. So see, This much high energy, this much high kinetic energy
Mm,
gets converted into the geokinetic energy. So where this energy will go? See, there will be a loss, there will be high loss of energy. And due to this high loss of energy, it means it will be more dangerous. The passengers or the car driver will get very high or very long injury, right? Why? Because they will be impacted by the high energy loss, the high energy transfer, whatever the kinetic energy it will be, now it will get transferred to the driver or any passenger. Is it okay? Are you getting my point? So due to the high kinetic energy and sudden stop, this drastic change in kinetic energy, this drastic change in energy is responsible for dangerous collision. Is it okay?
yeah.
There are some animals. No, see, in the sound, basically, we have some sound which are audible, right? Do you know what is the frequency range for audible sound? It is the from 20 hertz to 20 kilohertz. Do you know this? If the frequency lies between this range, this is audible sound, right? If the frequency is greater than 20 kilohertz, this is called as ultrasound. This is called as ultrasound. If the frequency is less than 20 hertz, if the frequency is less than 20 hertz, it is called infrasound. There are, see, humans can hear this audible range, right? We can hear this audible range. There are some animals which can hear in this infrared sound also. There are some animals which can hear this ultrasound waves also. Are you getting this? So for that, you have to read this passage. Please read it. Sounds that are
Okay. Sounds that are above the range of human hearing are called ultrasound. These sounds have wavelengths that are too short and frequencies that are too high for our ears to detect. Some animals, such as bats, use
audible.
ultrasound to communicate, and they use reflections from ultrasound to navigate in the dark and find insects to eat.
So now we have to search some animals which can hear this infrasound waves also. Do you know any animal's name which can detect, which can sense these infrasound waves?
Bats, whales,
Bats, I think they can respond ultrasound, I think. Yeah, see, some animals such as bats use ultrasound to communicate. They use the reflection from the ultrasound to navigate in the dark, find the insect to eat. Can you explain these lines? What are the information we are getting? See, this is your bat. Okay. So what's the information this is saying? Please summarize this.
summarize.
Okay,
Yeah,
please just repeat these things once again. What the information they are saying?
sounds that are above the range of
No, no,
human
this one
hearing.
only. Yeah, some animals from here.
Some animals, such as bats, use ultrasound to communicate, and they use reflections from the ultrasound to navigate in the dark and find insects to eat. Isn't that echolocation?
Mhm. So works on this principle. Have you heard this word radar? This radar. There is a sonar. This is also a device. Both and this bat. These three works on the same principle. That is the reflection of the wave. Have you heard this word radar? Have you heard this word sonar?
Oh no.
Okay, please see. What's the sonar is? It is the sound navigation and ranging. Sound navigation This is your syllabus. And ranging. What is the meaning of these words? See, sound means this device use sound waves for what? To navigate. Do you understand what is the meaning of navigation? To tell the direction, right? And ranging. What is the meaning of ranging? It can tell you the distance of the target object, right? So how it will, and where it is used? It is used in ships or some marine ships, we can say. How it
Mm-hmm.
will use, see, suppose this is the sea level and there is a ship here, right? So what the sonar will do, it will send a wave, it will send a sound wave inside the sea, and it will go till the bottom of the sea, and after reaching this bottom, it will get reflected and it will again come to the top surface after reflection. So, after calculating the time gap, the time duration between reaching to the bottom and coming back to this one, if you know this time duration, we have the speed of the speed of the sound wave in the water. These two things are known. Then we can find the distance, total distance traveled by the wave, and if we divide them by two, we will get the depth of the sea. Are you getting this? How the sonar will work?
Yeah.
Similarly, bats do the same thing. They generate a ultrasonic wave which we cannot hear, right? They generate an ultrasonic wave. Suppose there is an object here, so it will go ultrasonic wave. If there is an object here, if there is an obstacle here, this wave will get reflected again. So it sends its own wave. Okay, I this was my wave, and there it means if it gets reflected, it means there is some obstacle here, so it will change its direction. Are you getting my point? So yes, the bats use the ultrasound to navigate. Is it okay? And ranging also. So this was the sonar. Similarly, what is the radar? I think radar you must have heard. What is the meaning of radar? Have you heard this word?
No. It's
This
like where you
radar
locate something.
this radar mostly, this time in the warlike situation between India and Pakistan, if you have heard some news, some radar has detected radar. So right, so this radar works the same thing. It's also used for navigation and ranging, but in place of sound wave, it used the radio waves. So it is radio added, or we can say radio added navigation, radio added, radar, radio added, radio added radio added detection and ranging. Let me check. Detection and ranging. In place of sound wave, radar use the radio wave. Let me see the full form. Radar, radio detection and ranging. Radio detection and ranging. Okay, here I was writing. Radio detection and ranging. Radio detection, not radio added. ठीक. Radio det हाँ, ठीक है. Radio detection and ranging, right? So these three things are your work on the same. Now you have to see. any animal which can respond for infrasound also. Do you know? Have you heard the animal rhinoceros? Do you know rhinoceros? So rhinoceros
Yeah.
is such an animal which can sense infrasound also. Let me show you. Four graphs below shows the signal detected by a microphone. Which four sound were played? Okay, before this, can you tell me, Bhuvika, which energy conversion is done by the microphone? Microphone convert which energy to which energy? Can you tell me? What's the energy conversion happen in microphone?
I I do not know.
That's very
I think
simple. It
I think
convert your sound
sound energy,
energy into
electrical energy.
correct, exactly, electrical energy. And the speaker, what's the speaker do? Speaker does the exactly opposite. The electrical signal will gets converted into the sound energy. Okay, now please see this question.
Hmm,
Which is showing the loudest signal or sound?
the loudest is sound C.
Logic, absolutely correct. Can you explain?
The displacement is the highest.
Yeah, the amplitude. The amplitude is responsible for your loudness. Very good, very nice. See, the which graph is the highest in pitch?
Sound D.
Explanation.
Um, the gaps between each
See, pitch is decided by what? Pitch is decided by frequency, right? To find the frequency, it is the number of repetition. It is the number of repetition in each second. It means in 1 second. If the frequency is high, the pitch will be called as high. You know, girls have the high pitch than the boys. So you can write because the frequency of girls' voice is high, right? And there is a very logical explanation, scientific reason behind a, common thing if you have observed. If you have observed, Bhuvika, in most of the reception centers, in any department, in any hotel, in anywhere, in any office, at most reception centers, generally ladies are preferred, right? Why? What is the logical or what is the scientific reason behind this? Are you getting my question? What I'm asking?
hmm
Most of the time, in most of the organizations, at the reception centers where the calls have to be received or call has to be diverted, it is done by ladies, especially. They prefer ladies. Why? Because the ladies have the high frequency, and due to high frequency, we can say the pitch will be high, and due to this high frequency, the distortion is very less. The distortion is very less. Suppose from India, if a lady is talking to anyone in US, right? From India, if a lady is talking via telephone line from the US, any person, the voice of this lady will not deteriorate so much till traveling to the US via the telephone line. But if a male voice is being transferred via telephone line to such high distance, it gets distorted, badly. Are you getting my point? So this is the reason, this is scientific reason why ladies or women are preferred for this reception offices. Are you getting this point? Okay. So now we have to see which figure has the which diagram has the high frequency. So for that, we are considering the 1 second time, or we can see the time period. Can we find the time period? See, frequency is 1 upon time period, right? If the time period is low, the obviously frequency will be high. So we can calculate the time period. For the time period, you have to see the repetition of one wave. See, one wave. Yeah, it gets repeated here. So in this first diagram, the time period is 0.01 seconds. You can see here from here to here. In the second one, the time period is same. It is 0. No, no, it is not same. It is 0.1. It is 0.1. In the third one, it is 0.01. It started here and gets repeated here. In the fourth one, this time period is 0.005. You can see from here to here. See, time period is very less in all these. This is the smallest time period. So if time period is less, the frequency will be high, right? If the frequency will be high, the pitch will be high. So your answer is correct with explanation also. Okay, the third one. In which diagram cannot be heard by the humans? Now, how we can say which wave cannot be heard by the humans?
Um, hmm, which way?
Find
Sound,
Yeah,
sound A.
A. Can you find the frequency for each waves? So frequency is 1 upon time period. So it should be 1 upon 0.01. So obviously this is going to be 100 hertz. And 100 hertz is in our audible range. What is the audible range? What's the audible range? Audible range is audible range is 20 hertz to 20 kilohertz, right? Are you getting this kilo? It means I want to say 20 hertz to 20,000 hertz. If the frequency lies in this range, it will be a audible sound. Okay, the second one. The time period is zero point 0.1. So what should be the frequency? 1 upon zero point 0.1. So it should be 10 hertz only. This seems to be not audible. Yeah. The third one, it is again 0.01, so its frequency is 100 hertz. This is audible. Here, the frequency should be 1 upon 0.005. That should be 1000 upon 5. That is the 200. So here the frequency is 200 hertz. So it's also in audible range. So answer should be B. Have you understood it?
Yeah,
Okay.
I think it might be 80 hertz.
See? So frequency is 1 over time period. It should be 1 over 0.0125. That should be 1, 2, 3, 4 upon 125. It should be 80 times. Correct. Next, the second bit, the second part, second question. Which of the following is not a transverse wave?
Um, the visible light reflects off the surface of the ocean. I think it's D. Wait,
D.
no, it's not D. It is C.
C.
Mm-hmm.
You know, infrared waves comes in electromagnetic range, isn't it? See, it is
Okay,
the
then never mind. It's B.
yeah. See the ultrasound. We know sound is a longitudinal wave. It's not a transverse wave. We can check it also. This is the knowledge based question. Let's see. The ultrasound waves dolphin use for echolocation are longitudinal. See, it's a sound, so we can relate this with a longitudinal wave. So B should be answered. That's correct. Very. The third one. Here are four statements about the difference between the light waves we see and the sound waves we hear. Which of the following statement is true? So please read it and tell me the answer.
Here are four different statements about the difference between the light waves we see and the sound waves we hear, which is one true. Oh, all right. Oh, light waves are faster. Light waves can travel through a medium. No,
Right? We have to find the true statement. Which of the following statement is true?
can't both of them transfer energy?
Option D. You want to say D.
Yeah, but can't both of them? Um, sound waves are longitudinal, but light waves are
Okay, let
transverse.
us go one by one. Which of the following
Is
statement is true?
wrong. Is wrong.
Sound
B.
waves are transverse wave. That's wrong. Sound waves can travel through a vacuum. Wrong.
That's
Sound
wrong.
waves have a low frequency than the light wave. That's true. Sound waves cannot transfer energy. It's wrong. Sound wave have such a very low frequency. It can range from 0 hertz to something. Like a light wave has very high energy, very high frequency. Okay, please see this question number 4.